We're going to go through this worksheet, circuit calculations. So let's read the introduction. Regardless of circuit complexity, circuit designers as well as users need to be able to apply basic electrical theories to circuits in order to verify safe operation and troubleshoot unexpected circuit failure. In this activity, we're going to gain experience applying Ohm's law and Kirchhoff's voltage and current laws to circuits in order to gain understanding of circuit requirements and relationships between voltage, current, and resistance. So the first thing you're going to want to do is draw a triangle and put Ohm's law on your page so that you know how to use it. So that's going to be VIR, just like that. So let's look at this first question. We need to find whatever the value is it's looking for. So in this one right here, it's looking for current. So if we cover current, that means that it's going to be V divided by R. Okay, so let's plug in some values. So we're looking for I is equal to V divided by R. So V here is 3.5. So 3.5 volts divided by 470 ohms. On a calculator, it doesn't matter what calculator you're using, 3.5 divided by 470 is equal to 7.4. So as I is equal to 7.4, and that is milliamps. So MA. Let's move on. So in this one, we're looking for resistance. So if we cover the R, that would be V divided by I. So R is equal to V divided by I. So I is our current in microamps. So you have to notice that this says microamps. So if you see like a little U shape, that means micro. So that means we have to convert some stuff first here. So we want to turn this micro into milliamps because we'll get a better answer, a more rounded answer. So 15.5 divided by 1000 will give us our milliamps, which is what we want. So 15.5 divided by 1000 is going to give us 0.0155 milliamps. So now we can take that so now we can do this formula here. R equals 3.5 volts divided by 0.0155 milliamps, and that's going to equal 3.5 divided by 0.0155. That's going to equal 225,806 ohms. This is we have to put our answers in proper engineering notation. So this is in ohms. That's a lot of numbers here, so we need to divide this by 1000. So divide that by 1000. And we get 225 k ohms, kilo ohms. There's 1000 ohms in 1 kilo ohm. So that's why we divided by 1000 for this example. So our answer is 225 kilo ohms. Here we need to find voltage. So in this problem, let's find voltage. So if we cover the V, that's I times R. So V is equal to I times R. V equals to 1.4 milliamps multiplied by 22 k ohm. So this one's a little more straightforward. We do 1.4 times 22 equals to 30.8. So our answer is 30.8. So what I would like you to do for here, so 225, so 225 k ohms. Just put a square around your answers. 7.4 milliamps. Alright, let's move on. So we're going to calculate, so for each of the circuits shown below, calculate the value for RT. Be sure to put your answer in proper engineering notation and use the correct units. So for resistance total, you're literally just going to add these all up. But we have 820 ohms, and then we have this 1 k ohm right here, or 1.2 k ohm, so we have to convert this to just ohms. So that would be 1,200 ohms. Okay, so it's literally going to be RT is equal to, so we can say this is R1, this is R2, this is R3, and we're literally just going to add them up because this is a series circuit. So R1 plus R2 plus R3, so it's going to be 820 plus 1200 plus 150. Let's do that calculation. 820 plus 1200 plus 150 is equal to, RT is 2170 ohms, but we have to convert that to proper notation, so that's going to be, we can divide that by 1,000, or if you know how to do that math in your head, it's 2.17 k ohms. Okay, now we have a circuit that is in parallel. So let's do the calculation for that. So let's go ahead and make this 5.6 k ohm, 5600, and 8200, and 680 we leave alone. When we're calculating the total resistance for a parallel circuit, it's going to look like this. So that's a 1 divided by 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. We can say this is R1, R2, and R3. Okay, we'll plug that into our calculator. So that's, let's plug in these numbers first. So 1 divided by 5600. Alright, so using this formula, we're going to plug these values in. So if you have a calculator like this, you will press 1 divided by, and then use parentheses. So parentheses, parentheses. 1 divided by 5600, parentheses close, plus, parentheses open, 1 divided by 680, parentheses, plus 1 divided by 8200, parentheses close, close, equals to 506. So the total resistance for this parallel circuit is 564 ohms. Alright, let's look at question 3. So it says, using laws of circuit theory, solve for RT, IT, so the current total voltage across 1, 2, and 3, and be sure to input your answers into engineering notation. So let's do RT first. This is a series circuit, so for a series circuit, when you're calculating resistance, you're literally going to add them all up together. Okay, so that's going to be RT is equal to 470 plus, we have a 1.2 here, so that's going to be 1200 ohms. We're taking the kilo ohms and turning it into ohms, plus 270. So our resistance total is 470 plus 1200 plus 270 is equal to 1940, or 1.9 kilo ohms. our current total. So we know we have the voltage, we have the resistance total. So they want to find current, so if we're going to cover current, we can divide V divided by R. So V divided by R will give us our current. So we know that the total voltage we have right here was 9 volts divided by 1,940 ohms. So 9 divided by 1940 is 4.6 milliamps. Cool. Okay, so if we wanted to verify our results using Kirchhoff's voltage law, what we would have to do is, for each resistor, we would have to do V equals I times R. So for example, for this resistor, if we want to calculate the voltage across that one, you would say, so for R1, we would say the voltage is equal to 4.6 milliamps times 470 ohms. If we calculate that, we get that voltage across here is going to be 2.1 volts. And if we did that for each of these, we would get about 8.8 volts. If we did that calculation for each one of these, so that would be 1200, we would just plug in. So for R2, we would say 4.6 milliamps times 1200 ohms, and for R3 we would say times 270. If we would add up all the values, we would get something very close to the 9 volts. So that would verify our results. It's not going to be perfectly 9, but it's very close to 9. Alright, moving on to number 4. Using the laws of circuit theory, solve for RT, IT, I1, I2, I3. Be sure to answer in proper engineering notation. So we need to find the current total. So let's go ahead and calculate the current across each of these and the resistance across each of these. So in parallel, so this is parallel, RT is equal to 1 divided by 1 over R1 plus 1 divided by R2 plus 1 divided by R3. So let's just plug and play. So 1 divided by 8200 plus, we're taking this 8.2 and making it ohms, so that's why that's 8200. We'll do the same with R2, so that's 6800 plus 1 divided by 4700. That's resistance total. So again, on your calculator, 1 divided by parentheses 1 divided by 8200 plus 1 divided by 6800 plus 1 divided by 4700 parentheses equals our resistance total, 2075, which is 2.07 k ohms. We're going to take that number and find our I total. So for I, that's going to be voltage divided by R, which is equal to this 12. So 12 volts divided by 2.07 equals 12 volts divided by 2.07 is going to be 5.7 milliamps, or 5.8 milliamps. Alright, if we wanted to calculate the current across each one of these components, we would need to do V divided by I. So let's do R1 first. So we cover up our R. Well, no, we need the I, so we're covering up the I. For this one, it would be I equals 12 divided by 8.2. 12 divided by 8.2. We get 1.4 milliamps across this one. And you can do the same for these guys over here. Alright, now let's move on to our conclusion questions.